So these 45-minute sessions are pretty tight, so I'm gonna maximize time and we'll get started. We'll let folks who are straggling in can pick up in just a minute. So yes, you are in Beyond the Code, profiling and monitoring your application in PAS for OpenEdge. We're gonna go through the usual stuff while folks are still filing in. So who am I? Dustin Graw. You can reach me at dgraw@progress.com should you have any questions afterwards. I'm still a principal consultant, now in the engineering services group. This is a new group that sits sort of between tech support and directly with engineering. So we've got a hotline into all the brainiacs. So I've had 20 plus years in the field, so a lot of direct customer engagements. Our new group, if you've seen our various agile team names, we are the A team because, yeah, we pretty much swoop in and people who are absolutely positively stuck with a migration, we're here to help. So we are one of the engineering scrum teams, and we're happy to make sure that everyone has a successful engagement or a successful migration to PAS. So if there's any materials that we need to create to publish and help you with that, we're gonna do our absolute best. So quick agenda, we are gonna review the monitoring tools. So there's no code here today. We are gonna be looking at a suite of UI-based interfaces that we can access. I'm gonna prove that this is not just smoke and mirrors. There are successful customer engagements where we have utilized these tools and got people over the hump in implementing PAS successfully. It's important to establish patterns that will help you to measure, change, and evaluate your success with your application migration. I'm going to show you how you're going to gather metrics, and we're going to put those results to use. So I'm going to tell you what it is you're actually going to be looking for once you get these stacks of data. All right, so what are some of the tools that are available, and where might you find them? So two that first come to mind, JMX or OEJMX and the OpenEdge Manager web app. These are the OE Manager REST APIs. These are available in 11.7.4 and later. I recommend that version because there was a lot of changes even between the Service Pack 3 and Service Pack 4. You're going to find a lot better use out of that. And of course, these are available in 12, OE 12. These will be our primary focus today, one more so than the other, but I'll get to that in just a minute. The reason why these are lumped together is they're both going to produce the exact same output. So it's going to be a JSON payload that's going to describe the metrics that we're accessing. It's just two different ways of getting to that data. So in JMX, you would create a query on disk and you would run a particular binary that's going to talk to the Java process for Tomcat, and it's going to query that process to get its information, whereas the REST APIs are pretty much what they sound like. You're going to send a RESTful request using Postman, Insomnia, whatever your client of choice may be, and it's going to query the OE Manager web app that has been deployed to your PAS instance, and that's where it's going to get its data. Some of the queries work at an agent level, so you can say, all you need is a PID or a unique ID for an agent, and it'll tell you everything you need to know about every session of that agent. Some work at a more granular level. How and when you use those is kind of up to what it is you're trying to retrieve from the system. But what's cool is because one is a RESTful command and the other's a command line query, you can set up scripts, you can set up code, you can automate this so that it runs these queries, requests this data on a regular interval. And now if you start reporting at a regular interval and get data, now you can create nice pretty graphs of memory usage and that sort of thing. One thing to keep a lookout for, and we'll kind of get into this as we talk more about the OE Manager web app, is while you can run these at any time while your PAS application is running, there are some false positives that you might get because you could pick up some objects that are legitimately in flight. They're part of actual requests going through the system. So you have to be careful about when you access the data if you want accurate results. It's worth mentioning there are some other tools that are out there, especially since OE 12, the health scanner for PASOE. You may have heard of this. It uses a RESTful API. It sort of returns a snapshot of server health. So it uses a weighted algorithm where you say, you know, what concerns you more, CPU, memory, that sort of thing. And it monitors the system more closely and returns a score that says this server is healthy or not healthy. It's not really meant for code diagnostics, which is why we're not diving into it here. But it is useful to know if your system in the cloud especially is going to potentially be failing. And then there's some server-side profiling that also can report on a regular interval using JMX queries. It will send data to a remote PASOE instance. So yes, it does require another PAS instance to be created as sort of a collector of data. Due to the amount of setup for that, we're not going into that as well for today. So I'm going to stick with just some things that you can instantly turn on in your PAS instance and get some results right away. So, like I said, no smoke and mirrors here. We're going right into how we've used this. So I'm going to review 3 recent and successful engagements. No names. This is because everything that we found, completely honest mistakes or just code that, you know, had been running fine, and issues just hadn't bubbled to the surface until customers moved to PASOE, and there was much more performance and throughput for the system. So issues were magnified just much quicker. I'm going to walk through the processes that we use to diagnose some of these issues, and we're going to talk, of course, about how we mitigated the problems once we discovered what was going on. And hopefully this all proves that these techniques do work. They have been successful, so definitely I want you to be able to utilize this in your own application. So customer A, they were migrating from classic WebSpeed to PAS4OE. Their migration was not 100% successful because they had some random crashing of agents. Basically, agents would just suddenly disappear. They'd be killed. Customers suspected a memory leak, but they just had no idea where to start. We had suspected, and we did prove that the issue that they had was still present in their old WebSpeed code, but it happened faster under PASOE, again, because we were doing more with less running processes, but because we were doing more with that, the issue compounded much quicker. And to their customers, it presented as basically random disconnects. The short story is, when you kill a PAS agent, because it's essentially running multiple sessions, and each one of those sessions is a connection, if you've got 16 connections and you kill the agent, you've just killed all 16 threads or sessions. So what did we do? Well, we used what's called an ABL objects report and the session metrics to diagnose the issue. We found that there was a persistent procedure handle that was being created for every single request to the system, but there was absolutely no cleanup. There was no delete object for that handle. So the solution was, we said, well, just add a finally block into your procedural code and make sure that this thing gets cleaned up when you're all done with it. So as soon as we changed that, we went from a PAS instance where each session was climbing steadily above 90 megabytes each to essentially flatlining at 20 megabytes. And this is one of the graphs that we were able to produce from the data. So as we were sampling on an hourly basis, we ran their application. We had a JMeter set up and was running through their application for 5 whole days, and we just kept seeing the memory climb and climb and climb and climb. This is after the fix. I'm going to go back. So that was climbing well over and approaching 100 megabytes per session. This is just looking at one specific session. So multiply this times 16 or 20 that they had running, versus that pretty much flatlined at about 20 megabytes. So just fixing one leaking handle solved their issue. And again, running for 4 days on this test, we hit a stable memory state. Customer B, another migration, so from classic app server to PAS4OE. Again, reported potential memory leak, just didn't quite know where to start. So We broke out the ABL objects report again, and we noticed that there was a list of growing artifacts. So there was temp table handles, there was all kinds of stuff sitting out there. For this particular customer, they only had 11.7.3. That was the first appearance of this tool. So we said, all right, well, you won't have, you want to have all the APIs that 7.4 has, but we can at least figure out what's going on your production system if you just drop this web app into your PAS instance. So yeah, we found all kinds of things from temp tables that were being passed. Essentially, it was creating new copies. So we suggested, well, why don't you use by reference to pass a reference to the temp table instead of fully copying it. They didn't clean up object instances, and they were creating records, not releasing them. It was little things like that that we started fixing. There was still one item. It was hard to find, but we located a temp table that was being used, and then after its use was still lingering. Once we got rid of that, it made a huge difference. So on the left, you can see the number of objects for each of 3 sessions in an agent just kept growing from 42 to 50 to 56. There was definitely a linear climb. Once we eliminated the temp table issue, pretty much flatlined. Question? It was one that was being passed in from the web. So it was an API endpoint, a RESTful endpoint. They were passing the temp table in, but at the end of that request, temp table had already been, for each used. All we needed to do was add a delete for that temp table handle that was coming in. And that's what it was just a temp table handle. I can't remember specifically. All right, so that was customer B's issue, and yeah, so that all we were doing is we didn't even look at their memory consumption. We just knew something's leaking, and once we showed them that, they were able to find even more in their code that they're still making sure that they're cleaning up. All right, customer C. This is another migration, classic app server to PAS for OE. This one was much more complex. They were using a distributed and load balanced environment in AWS. That didn't necessarily make it more complex. It was just a lot more moving parts. So there was a lot to isolate. We did figure out that there was an inconsistency in response time. That was basically the crux of their problem with their customers. Some people were saying, well, sometimes I can request a system request. Some endpoint, it'd take a second to come back. Others, it takes 7 seconds to come back. So there was a wild swing there that we needed to figure out. And we had tried all kinds of things. We found that if we upgraded their EC2 instances to something that had enhanced networking, that gave us much better throughput within the AWS environment. Because that was using jumbo frames, we could maximize the message size between the client and the database. So we set that to its maximum value and found that was a huge improvement. And we noticed that little differences even inside AWS between their internal data centers, just minor fluctuations of 1 to 2 milliseconds can make a huge difference. So we isolated everything that we could, but some APIs were still running slower than others. So here's an issue of when the problem isn't actually the ABL code. So there's one metric endpoint called requests, which basically says what was executed in ABL. So every time that something goes through the ABL client, it's marked in this metric. So we could see that no matter how long it took from the web server's point of view to execute, the ABL code was still running consistently. It was like a half second or less to actually execute the code. So we knew it wasn't a database problem. The code is behaving consistently. But the Tomcat access logs were still showing that, well, it's 7 seconds to run this code, but ABL says it's only taken a half second. What's going on? And we could also see that on the ABL or on the PAS side, the OE connections, for one agent, if we had set 20 or 30 sessions being available, only 5 or 6 were being utilized at any given time, even though we were beating the crap out of the system. So definitely connections were underutilized. Somewhere there was a bottleneck. What we located was a customer for this particular API was running through some ASP.NET code. So they were running through IIS, and it was making an app server connection to the PAS instance. So it was using the app server transport. That ASP.NET code as the middleware was actually the problem. So it was IIS. So we started looking and found that in the .NET framework, there is a default threads per processor core value. It's set to something like 20. The maximum value is 40. So we said, okay, something's bottlenecking here. Let's see what it is. And we were actually able to use the Process Explorer, and we could see that the CPU utilization for the worker thread was not being maxed out at all. CPU was extremely low. So what we did was we changed the value, reran the test. Now all of a sudden we had not only more worker threads, but they were working even harder. Now they're hitting like 60, 70% CPU. So we know that they're churning through data, through requests actually, and that instantly improved throughput, and we started getting way more requests back on the PAS instance. So in this case, IIS was the bottleneck. .NET needed a small tweak, and that let us push through more data, and that resolved the throughput issues because now we're consistent. Nothing's queuing up at the IIS side waiting. So we were able to use these metrics to prove that PAS is not the problem. We need to look elsewhere. All right, so how did we do this? Well, the key is repeat, repeat, repeat. You need something scripted. You need to come up with you need to use a tool that can let you repeat things without you having to worry about it. So JMeter, SOAP UI, Load Runner, all of these are tools that you can set up scenarios and you can run them, and they will run the same way every time, reducing the number of variables that you're potentially changing. You do want to do this in a realistic way. So, don't just say, oh, I'm just going to find this one endpoint and beat the snot out of it. No, you need to kind of get some good coverage of your application. Make sure you're running everything that a normal user would be running, just so that you can exercise as much of the code base as possible. It doesn't have to be 100% code coverage, but you need to use it in a realistic way. You need a process for measuring change. So whatever you do, make sure that it's something that's, like I said, realistic. You're going to run it, the first time with your normal code. You're going to run this test again every time you change a variable. So you want to keep this consistent. Those variables, there's so many different things that you can tweak, from a Tomcat level to number of agents, number of sessions. So many variables can be changed, so you need to make sure that you're changing as few at a time as possible. Rerun your tests, change a variable, measure the output, and basically that's it. So change, measure, evaluate, and repeat. You follow those steps, you will actually see changes, and you won't be overwhelmed by, I changed 6 different things, which one of them actually worked. All right, so what do we do with our customers? So exactly that. We work with our customers to craft the path. In some cases, what we'd do is we'd find, what's a general user going to use? What would an expert user or a high-level sysadmin use? What path would they take through the system? So that let us create different scenarios that we could run. Sometimes we had to run for extended periods, almost a week for one particular test, just to get enough data to prove that yes, this is happening. It's not seen in a day. It's not seen in an hour. It's seen over a week. We use those metrics and we plot it out, nice pretty graphs, because it's always nicer to view a picture than just looking at numbers on a screen, where everyone's more visually oriented. So that was a critical piece, was taking that data and turning it into something visual. That also let us see the peaks and valleys and let us know, well, what is it that we needed to look at and review further. Any changes that we need to do, we made sure the customer fully understood what it is that we're asking them to add to their code, if anything. We would help them modify the code, compile it, and deploy the changes. And then, of course, that whole lather, rinse, repeat. Rerun the tests, evaluate the changes, and see if the test pattern holds. You should see something different every time you run your tests. And it's nothing that you can't do on your own. I assure you of that. So how do we do this? Well, we're going to gather some metrics using the OE Manager REST API. The metrics that we're going to look at, or that are most useful to you, agents. This endpoint will give you a list of all the agents for a running ABL application. So remember, PAS can have multiple ABL applications inside of it. So different runtimes with different ProPath, different databases. Each one has a unique name, and each one then can have multiple agents. The agents report gives you, lets you match up the PID to the OS. We're also going to use that to gather information about the sessions. So sessions, most importantly, shows you the memory usage. So that gives you a value in bytes that you can now plot and see. If you total up all of the session memory, you should roughly match the memory that the agent PID reports to the OS. ABL objects, anything that's out there, so buffers, handles. This is all coming off of, it's basically an older KB article that would let you loop through and do, for first object, next sibling, next sibling, next sibling, for first procedure, next sibling, next sibling, next sibling. It would let you loop through all these different internal stacks. That's essentially what it's doing. It's just outputting in a nice, pretty JSON payload for you. And requests, these are going to track those internal ABL requests. One thing that's really neat in OE12 is right out of the box, Tomcat now comes with a special unique identifier in the access log. And the data that comes out of this request API on the ABL side has that same identifier. So now when you look at both sides, you look at the Tomcat access logs and you look at the ABL request log, you will be able to match up. This web request ran this ABL code. So you can get your whole life cycle through that. All right, so why do I prefer or suggest the REST APIs? Well, there's no command line, so you don't need administrator access. JMX really only also runs when you start via TC-man. So if you're in Windows and you're using Developer Studio, usually you're either using the OpenEdge admin to start it, or you're starting it through the Developer Studio. JMX only works correctly in Windows if you start by TC-man. On Linux, it's usually a foregone conclusion. You have to create a query on disk. So there's this long query string that basically says, what item am I looking for and what are the parameters that I need to run it. So that first long string, that's what your query looks like. To me, I'd much prefer the second one, which is just hit this one URL endpoint. I can fill in my variables in the URL itself and hit the endpoint, and I'm done. I don't have to have admin access, file system access, any of that. If you were to automate this, another good thing is you don't need any OS command calls. You don't need to go dump output and then pick it up and read it. The APIs, you can just grab the JSON output automatically comes back. So all you need is to grab that data and process it. Yes, so I'm going to get to that. So right now, for the OEJMX, that's what the command line query would look like. It would be you'd run the batch or shell script. -R says just remove the headers, and the -Q says where's my query file, and then it dumps it to a JSON file. The other reason why I like the REST APIs is, yes, you can use the OE HTTP client to call out to make these requests from inside of ABL code. What's neat about that is then you can put that code into like a deactivate procedure for your application. So when you are done with a request, the deactivate should run after you have done any cleanup. Any finally blocks have run for your code. You are at the application boundary. So this means that any data that you obtain from the system at this point, as long as you're calling for that same session on which you're running, you should get back a list of objects that should have been, completely cleaned up. If you see anything in there, then well, something's probably leaking. Oops, I should have gotten on one more. So yeah, that's mainly for the ABL objects. That's the big one. You want to make sure that if you're looking for that data, you want to run that API when there's either no load on the system or you know you are executing the code on a session that has completed execution and there shouldn't be anything in flight. Other benefits, like I said, you can easily use OE HTTP client. You can run it during startup and shutdown, or some things can be run during startup and shutdown. Some can only be run during activate and deactivate, and that's because at that stage, you actually have a request context. So you know exactly what agent and what session you're running on. It's typically already present. If you did a pasman create and you use the -f command, then this web app's already there. If it's not there, and I probably should have said instead of for production, just for any non-development system, if you want to install this, it's simply tcman deploy, and then the oemanager.war exists in your DLC directory already. So all you have to do is point to that and it'll deploy it. Here's where it gets cool. So in 11.7.4, another benefit to using that version or OE12 is they now package in there an Open API or Swagger document. So this interface gives you an easy way to integrate or test these APIs. You don't have to go look at the documentation. It is the documentation. So run this in your code, run this against your code, before you go to production, do a sanity check, make sure everything's working the way you think it is. Like I said, you can run this at any time. You just have to mind about that request boundaries. If you're on a development system, you're probably the only one working on the code. So if you make a request to the server and then you run the API, that's probably going to be just fine. By default, it is disabled for security. So one, this is not typically deployed in production, not without adjusting security. And then the Swagger document itself is disabled, but we're going to walk through that process real quick. So, all right, so this is what the quick glance at what the Swagger interface looks like. And we'll get into that a bit more. So how do you enable it? Real easy. Once you have deployed the web app, navigate to your Catalina base. That's the location of your PAS instance. Go into the web apps folder, go into OE Manager, and look inside web INF. You're going to find OE Manager security container. This is the default security file for the OE Manager. Container basically says it inherits from Tomcat overall. So the password, username and password for Tomcat, that's what you would use for this. You're looking for a documented line. So it actually does tell you to access the Swagger UI, which is disabled by default. User has to uncomment the below line to enable it. And so all you do is you remove the little HTML comment flags on each side of this line, the /doc line. Save the file, restart your PAS instance, because anytime you alter security, you have to restart Tomcat. And then just point to the /OE Manager /, and that trailing slash we found is important. If you leave that off, it will keep telling you access denied because it can't find the default index.html file. So you need the trailing slash, and then your default username and password is Tomcat. Like I said, that just inherits by default off of whatever the users.properties file of the Tomcat instance. So what does that look like when you're actually using it? So you're going to get a nice little interface with all the URLs, and you should see like a little bit of text off to the side, like this one says, get application app name agents, and the description is just get agents. That's pretty much it. You click on it and it'll expand, and you'll see a little try it out button. Click on that, and what it'll do is it'll put the screen into sort of into a read-write mode. So anywhere there was a fill in the blank, so in this case, app name is a parameter, it's going to change that to a text box, and you just fill in the name of your ABL application name. By default, if you're just running one ABL application name, it's usually the same name as the PAS instance itself. And then once you fill in the blank, you hit the execute button, and there's a whole responses area that shows you what comes back. So we'll look at an actual example. So most of the APIs that we need are going to need that API, or going to need an agent ID. That agent ID can be a PID or a unique identifier that comes back from the agent's endpoint. So this is what your response would look like. This might be a little easier to see once you download the slides. But in that payload, there's a result object. Then there's an agents array. Inside of there is the agent ID, the PID, and the current state, available, idle, busy, etc. So you need just one of those two values, either the agent ID or the PID. So what does that get you? Well, once you have that agent ID, now you can move on to other APIs like session information. So this one, get OE Manager applications, ABL app name, agents, agent ID / sessions. Again, just fill in the blanks, hit execute, and this is what you'll get back. You'll get a result with an agent session array, and it will be all of the sessions for that agent. And inside of there, the one that you'd be most interested in is session memory. And that's the one that's labeled in bytes. So grab that value. Like I said, if you take all of those byte values and sum them up, you should approximate what the OS says is the memory footprint for the agent overall. And any difference is pretty much the overhead of the agent itself. All right, and then ABL objects report. This one's a little bit more complex. You have to actually tell the PAS instance that, hey, I do want to monitor for this. So you have to turn this on first. Again, with the Swagger, the OpenAPI screen, this is real easy. So if you locate the put statement for the ABL object / status endpoint, you have to send a JSON body that says, yes, enable this. So you'll set the enable true text in the little text box, and again, hit execute, and it'll come back and say result status true. So it's enabled. Once it's enabled, run your code. You run any code. And then what you do is go run just the get ABL objects endpoint, and it will come back with a report. That report will essentially contain a ABL objects array, and inside of there will be the session ID and a list of objects. So if there is anything that's leaking or been left behind, that's where you're going to see it. And then lastly, the request information. This one behaves a little bit different, but it's again another one of those. The first time you hit this endpoint basically tells the system start tracking. So unlike the ABL objects, there's not a separate toggle for starting and stopping. I think that's because ABL objects is doing a lot more behind the scenes, so you really need to be sure that you're turning it on for good reason. This one, the first time you hit the request endpoint, you're not going to get anything back. It's basically just telling the system start tracking. From that point forward, it begins a rolling list of the last 1,000 requests. That was a hard-coded limit just to keep stuff from overflowing too much. And then what you'll see coming back is an agent request array, and that's going to tell you what was the procedure or the class method that was executed, the session ID, the start time and the end time. So if you subtract the start time from the end time, you get the actual elapsed time. There's an internal sequential request number that's kept up with. And then for OE12, you'll find a client ID, and that's the value that matches back to the Tomcat access log. All right, how do we put this to use? Well, the ABL objects, what you are looking for here is anything that's repeated basically more than once. If you see the same piece of code, same file, the same line number, but different handles, well, something's being repeated and not being cleaned up. So anything that repeats quite often, that's something that should cause concern. That's what's going to compound over time. Generally, if you add a finally block, most people forget that finally blocks do run even if there's an error condition. So even if you have a catch somewhere, the finally block still gets run for that block. So make sure that you clean up even in the event of an error condition. And we've seen that several times where a customer said, well, I'm getting this error condition, we should be fine. No, that doesn't mean that your code cleaned anything up. It just means you hit an error and you stopped execution early. Everything that executed up to that point, if it's still in memory, it's still in memory. We have found that the garbage collection process in the ABM does work exactly as it should, but you have to tell it sometimes that, yes, I am officially done with this variable, with this handle, with this object, whatever. So if you define a variable, my practice is create a finally block and add a delete statement immediately, just so that you remember, okay, if this is going to be an object instance, I'm going to delete it later. So create your variable for your object and then delete it. If you create a record, release it. I know there's a philosophical debate on whether you need to even release records. So far, it's not failed me. I put the release in, it works just fine.
There's a very tricky one if you use a table handle. You have to delete that.
And that's another one is, so yeah, so the last one for the open it and close it. If you open a query, close the query. If you open a socket or a file, close it. Pass by reference has been hugely helpful for temp tables or data sets. Now you're literally, you are passing a reference rather than creating an entire copy of that temp table or data set. The answer that I give is, well, when do I know to use that? Try it until it doesn't work. If you write your code and everything's working fine, go back and look through it and just double check. If I'm passing a temp table or a data set, if I add a by reference to this, if the code doesn't break and it still keeps working, then great. Now you probably just saved yourself a headache down the road. If it does break, well, then take the by reference off and maybe change it to just passing a straight up handle instead of a data set handle or temp table handle. So there's other ways that you can mitigate that. Session memory. This one's pretty easy. Every time that you take a snapshot of those sessions and you get the values for the memory, just keep track of the time and the memory for each session. And now, guess what? You can create a graph off of that. If you keep seeing the memory rising as opposed to hitting a plateau, well, that's probably cause for concern. You need to dig a little deeper and find out what's going on. The reason why this is also useful is there's no other way to really get a high watermark easily. So you want to find out, if I've been running my application for a few days now, it's testing or I'm in production, how much is actually being consumed by each session. Running that sessions API is going to give you some information about, it seems like each session settles around 70 megabytes. Once you have that value, now you know for that application, that's what you more or less can expect. This is a very application specific, so it's not a one size fits all. You can't just say that every application is only going to use 20 megabytes or 30 megabytes. It's going to be entirely dependent on what your code is doing. This one has bitten several customers. In Linux, there is a process called the out-of-memory manager. This will scan and look for, if the system begins running low on resources, especially memory, it's going to seek out the largest consumer of memory. Unfortunately, because of the way that all those sessions are rolled up into a single agent, rather than having one classic app server agent per request, more or less. You have all those sessions rolled up. Guess what? That thing's got a big target painted on its head. So if the operating system says, I'm running out of memory, guess what it's killing? So you can check to see if this has happened. Just do a grep for case-insensitive killed process in your var log messages. And you should see something about, PID was killed by OOM. That'll tell you immediately if you've been victim of that process. Windows, it's more the swap file that you have to look out for, but Linux, OOM will get you. What can you do with this information? Well, you can size your application appropriately. Sorry, math ahead. So how does this work? Well, you can figure out what your agent memory is by taking that average session bytes, multiply it by the number of connections you've configured per agent. Now you know how much memory the agent should be taking up. What about the ABL application itself? Well, take the agent memory, multiply that by the max number of agents that you said could possibly spin up. Going further, figure out, well, for the PAS instance, sum up all of your ABL applications, and now you know, okay, I got a ballpark figure of how much this entire PASOE instance is going to take up in memory. And then lastly, all of your PASOE instances that you've calculated, sum those up, and now if those all live on the same machine, now you know ballpark of how much the PASOE instances are going to take up. So taking that into consideration, tack on your usual OS consumption for OS operations, anything else that's running on the system, add a little percentage for memory growth overhead. And now you know if you need a system that requires a minimum of 16 gigabytes, 32 gigabytes, 64 gigabytes of memory.
What happens when you set your max agents and your number of current requests exceeds the number of agents?
That's a whole other discussion. I will happy to take that up later. So the request information, this is the last one. So this is easier to parse in OE12 thanks to it's what's called enhanced logging is what was added to the Tomcat access logs. So Tomcat has a timestamp with milliseconds. It has a OE request ID value. The metric, as we went over, has what's called a client ID, and that matches up to that OE request ID, and it lets you create a one-to-one match between the two. One caveat is the Tomcat access log currently that ships in OE12 does not have the %D token, which basically is the elapsed time in milliseconds. If you just insert that into the access log, now you know exactly how long the web request took, and you can compare that to the ABL time. So ABL execution time is just the reported end time minus the start time, gives you that in milliseconds. And if you compare the two of those, take your Tomcat time, which should always be longer, minus the ABL time, now that gives you an overhead time. So if you see an increase in overhead, something along that communication path between Tomcat and PAS is causing an issue. So the major lessons learned: small leaks plus time equals big problems. This is the number one killer. People don't really consider how much a small memory leak can cause until, yes, PAS can run and run and run and run, and by the end of the month's running time, suddenly you're like, why am I using so much memory? Well, something's leaking out there, and you don't see it on a quick unit test or in QA testing. You see it in production. So memory consumption matters for PAS stability, and it's not so much PAS itself, it's sometimes the operating system. So that OOM killer has bitten us several times, bitten several customers. Windows dealing with swap disk. As soon as you start dealing with moving memory between, dealing with that file I/O, that's going to be a killer for performance. Once you can start running these metrics and start getting some numbers for your memory usage, now you can start predicting future growth. Again, that's going to be very specific to your application, but it should help you prevent you from overcommitting system resources. So if you say, oh, I think I can just add one more PAS instance to this server, it should be fine. But really, did you crunch the numbers? Did you do the math? Are you certain that you're not going to overcommit? And all of these APIs or these metrics will help you isolate the application layers and figure out exactly what's going on. And of course, goes without saying, but you really should be testing this in non-production environments. So yes, I know sometimes stuff only rears its ugly head in production. That's unavoidable. If your application is properly secured and a DMZ, all that, then you might be able to install at least that OE Manager web app and start gathering some metrics in a non-destructive manner. But again, that's up to you and your security and DevOps teams to figure that out if that will work. But yes, please test in your development environments before you go to production to look for any memory leaks. I'm going to say let's do questions after because we're about out. I wanted to share one more thing. Yeah, I'm an Apple guy. I'll do that. What about automating the results collection? Well, I've got bonus material. So there's automation using Spark Diagnostics. So we created, as part of our open source Spark toolkit, there's a little diagnostics procedure library that you can drop into your application, and there's instructions out there in the project about how to set this up. You can basically set it to run on the schedule. You can say start at this date and time and end at this date and time. Do I want to track the memory, the ABL objects, the requests? Do I want to run a profile on all my code for every request or run the the code profiler across the entire session. All that stuff can be set up. And basically, once you start gathering the data, it just dumps it out the disk. And then what you can do is everything has been carefully named and organized. You can then pull that data and start parsing it however you like to produce your graphs and other visualizations to look for suspicious data. So I will leave this up there. You can mark down that URL or grab the QR code. And that should take you to the additional slide deck. So, yeah, so these slides will be available. I'm not sure if the supplemental material will be part of that, but this should be hosted on a Dropbox account that's public, or once you have that URL, you can grab that content. But yeah, 45 minutes are a killer. I'm now 43 seconds over, but that's it.